Good morning and good afternoon, everyone. Welcome to the Mendix Community webinar. I'm Jan de Vries, and today we are going to dive into the deeper end of the pool with cognitive services and Mendix. Joining me today are Jeff Goldberg, Platform Evangelist at Mendix, and Adlai Gordon, Solution Architect at Mendix. During the webinar, you can ask questions using the Q&A window, and to chat, we invite you to use the group chat function. After the presentation, we'll go through the questions and answer them as best we can. The Q&A will be added to the webinar page afterwards, along with a recording of the webinar. All right, let's get this party started. Jeff, Adlai, take it away.
Thanks, Jan. Hey, Adlai, how's it going?
Good, Jeff. Awesome. How are you?
I'm doing great. So I want to thank everyone for joining us today because we've got some cool tech we're going to play with. As Jan mentioned, we're focusing on cognitive services and implementing AI, machine, and deep learning into Mendix apps in this webinar. Adlai, you've been diving into AI training, helping us with some demos at Mendix World and for our customers. Is the Skynet apocalypse of squids running the Matrix coming anytime soon?
Nah, stop watching that sci-fi junk, Jeff.
I can't get enough of it, so I'll be asking you that in the future. But to start, for this conversation, we're going to chat about some of the challenges we're all facing getting our AI and ML projects into production. Then Adlai is going to take us into the scary world of AI training, only to show us it's actually not that frightening. Last, we'll wire Adlai's work into an emergency response application that helps classify and prioritize the proper emergency response. If you joined us a couple of weeks ago for Low Code in 30, I joked about Hollywood's characterization of artificial intelligence and how many of the businesses we work in have been trying to figure out where AI and cognitive services fit into the products and services we offer. In my research, I found an article about why businesses fail at machine learning, and then after recording the webinar, Medium recommended an article on why AI POCs fail to make it into production. At a high level, the latter article nets out that saying AI POCs are experiments. They lack the data, the variables, and the real-world costs associated with a production solution. The former article states that businesses are spending their money hiring data scientists to perform machine learning research rather than taking advantage of the research done by others. I look at it as an 80-20 problem, except that many companies, like these articles suggest, are returning 20% of the value for 80% of the effort. This is where alternatives like the cognitive services from Google, Amazon, SAP, IBM, and Microsoft come in handy. They lower the barrier to entry for AI and machine learning, and with the variety of offerings they have on the menu, they'll cover about 80% of the use cases at a lower cost and less effort. We're not trying to build superintelligence here, and if we were, this webinar would need to delve into some headier topics like AI safety, which you can read more about in this very interesting Popular Science article I found a couple of days ago. See, Adlai, it didn't take me long to get back to the robots are going to end us. But seriously, what we want to do here is take advantage of what this article calls narrow AI. These algorithms and artificial intelligence services have superhuman capabilities, but their competency is limited to the scope of their programming. So even if the AI learns, as is the case with the service Adlai is going to talk about momentarily, it learns within the parameters and scope of the solution. Okay, Adlai, let's talk about the use case and what you did to stand up a machine learning AI to help us.
Sure. So in the run-up to Mendix World, we planned a technical session in partnership with Microsoft to showcase the breadth and the depth of cognitive services they have available and our connectors in the App Store. One of our favorite use cases is face detection. One of our customers is using to deliver insurance quotes with it. We wanted to explore more use cases and other cognitive services offerings out in the marketplace.
So what did you find?
It was actually, I think it was you that had seen the release of Microsoft's Custom Vision API that allows you to train the AI yourself to detect whatever you want. We got together with my teammate Mike Schiraldi, and we brainstormed some ideas and came up with an emergency response app.
That's very cool, and I think it's at this point I walked away because I had a bunch of other Mendix World stuff to do, and you and Mike took over. Tell me more about this emergency response use case that we dreamed up.
So we thought of an idea where someone who sees an accident or a fire or something else that they wanted to report to 911, they could take a picture on the application and send it over to 911. It would have the description included. We could pull the GPS coordinates from their phone or the picture, and then it would get sent to dispatch. And then we could actually use that machine learning to prioritize or to help prioritize that image. So for instance, if there's a fire, then we should send out the fire department right away and have that be a prioritized image. But if the machine learning algorithm realizes that it's just a picture of a cat in a tree, then yes, we'll send out the fire department with a big ladder to rescue it, but maybe that shouldn't be the highest priority. And we realized that machine learning could actually help us identify the priority of that image.
That's really cool. And if you think about it, along more different vectors, right? You mentioned accidents. Let's say there's a 5-car pileup, right? People use Waze all the time when they're basically crowdsourcing traffic. This is a way to actually crowdsource emergency response, so that if you take that picture and you see that fire, you see that accident with multiple cars, when that all goes through the machine learning sausage maker and gets sent over to emergency services, they can basically make the judgment call, oh, there's actually 5 cars there, or even the model could actually detect how many cars there that are in that accident and essentially send the appropriate amount of emergency services, so that you're not sending too little, which means more people have to be called, which takes even more time to actually solve the problem, that sort of thing. Would you tell me a little bit more about what you thought about in those cases?
Right, that's exactly what we're trying to do with using this machine learning algorithm to help us identify information about the images that were sent by the crowd.
Cool, very, very cool. All right, so let's get into this a little bit more. Walk me through this, because for someone like me who already recognizes it's easy to drag and drop stuff into Mendix once you've got a module built, right? We've done that already. We've demonstrated that in the low code in 30. So that in a lot of cases is the easy part. For many of us, when we're thinking about using these AI and machine learning tools, I actually think I'm going to have to write Python, or I'm going to have to figure out how to do Amazon Lambda functions and stuff like that. But that's not what you encountered at all when you started using this Azure Custom Vision API. So tell us a little bit more about what the process was.
Right, so first I started just reading a little bit about the Azure Custom Vision API. They have some nice documentation on their website, and it looked like you could really simply just upload some images, train those images with certain tags, and then go ahead and they give you an API to send a new image and see and get that classified. So I wanted to see how that worked. Jeff, I had never actually made Azure Cognitive Services before this. So first I had to make sure I had a Microsoft account. Once I had that, I was able to log into the Azure portal, which you can get to by just going to portal.azure.com. Log in with your Microsoft account, and then that's sort of their homepage for all of the information about Azure.
Now, I've been to Azure before, and actually I've used Azure like years ago, and the portal was absolutely terrible. Has it become better?
I don't know what it looked like before, Jeff, but I've learned it a lot better recently. And the really nice thing is they have a search bar at the top that allows you to find anything you want. If you don't already have a Microsoft account, you can create one first, and then let's get started.
Great. So now can we use our cognitive services?
Not quite. First, they need to know how they're going to bill us. For this, we'll create what's called a resource group. This is the layer that connects the resources you have with your Azure subscription. There's a shortcut to resources groups on the left panel of Azure. Click Add and fill out the fields to create one. My free trial expired, so I'm setting mine up with a pay-as-you-go subscription.
And as I mentioned earlier, cost does become a key consideration when you deploy these solutions to production. I can't say the costs are hidden because they're pretty explicit about how much things are going to cost. But if you're looking to improve accuracy and have a super accurate model, or your transaction volume increases because you've built a popular app, it's not going to be cheap. So you definitely want to think about what your plan is for scaling and popularity of your app as you build it. That said, for the right use case and return on investment, it really does become easier to justify.
Good point. Coming back to building out the functionality, all we need to do is search for custom vision in the marketplace. Fill out the form. I'm going to use the subscription and resource group from earlier. Click Create, and now we have our resource group set up.
This is pretty simple. I just pick from the drop-downs, and then I can go.
One more thing to take note of here is the API keys. We can find them by searching for cognitive services in the search bar at the top. You can see that we've actually made two new services. One is the API for training, and one is for predicting. To get started, we'll be training the algorithm by just uploading images. But if we want to get predictions later with the Mendix app, we'll actually want to take note of the API keys for prediction.
Okay, so just to confirm, the API that we care about here is the prediction API, right?
That's right.
Okay.
So to get started, Azure actually has a separate homepage for training your custom vision. Just go to customvision.ai and log in. From here, we'll make a new project, give it a name, description, and connect it to that resource group.
I click New Project. I add the name, and the resource looks assigned. Now what?
There's an option here to use classification or detection API for the project. For our project, we'll use the classification API because we want to have the AI identify the emergency so we can target the appropriate response.
Looks like we don't have any images yet, and it seems like adding them one by one from Google is going to be pretty time consuming. Is there a way for us to go faster?
I was worried about that at first, but then I realized Google. Turns out there's an easy to use Chrome extension called Download All Images. Then I could do a search on Google Images and download all the images. For this project, I did 3 categories: car crash, fire, and a cat in a tree. I did a few different searches to compile the images so I could grab a few hundred for each category.
And then we upload those into the customvision.ai website, right?
Yes, but first, I actually want to set aside some images the algorithm doesn't know about so we can test how well it works after we train it. Then, all we have to do is click the Add Images button and upload each of our training sets. You can give each batch a tag. I use crash for the car accidents, fire for the fires, and cat for the cat stuck in a tree.
Okay, let's do that now. I've got the fires. I'm going to download that right now and save that zip file. Now, search for cat in a tree. You can see from the screen we already grabbed the car crash images. And once we have all these images, then all we need to do is unpack the zip file. So we'll do that next. Okay, and now that we've basically unzipped everything, we can proceed to uploading. All right, so if we go back to our project on customvision.ai, and it's still waiting for us to add images, we can go ahead and navigate to those folders, and we'll upload the images just like that. Now when we upload them, This is our opportunity to classify them, right? So now we can put in the tags. So we'll call this a fire and upload the images. And once they're uploaded, we can go through them and select certain ones that we want to delete from our set. We can also change tags. We can do a bunch of other things with the set of images we've uploaded. Let's go ahead and upload the cats and trees. Tag those as cats. And we'll just repeat the process again for cars. I see this negative tag option. What's that mean?
I didn't use that for this project, but essentially you upload a bunch of images that specifically are none of those tags. For instance, maybe we add photos of nicely plated lunches so that if people accidentally use this app instead of Instagram to share their food pictures, then the entire fire department doesn't get called out. One more thing to do. Once we're happy with our sets of images, we can just have to click the green train button in the top right. This will take a minute or two.
That was much easier than I expected. How do we go about testing it?
Super easy. Just click that quick test button at the top, upload a test image or give it the URL, and see how well the algorithm worked.
Very cool. Let's go ahead and check this out in the context of our emergency response app. As Adel mentioned, the emergency response app was something Mike Shirali built to showcase a number of different cognitive services capabilities offered by Microsoft. Chances are there are other vendors with similar items, but we're sticking with Azure today. The quick tour of the dashboard here shows a map where emergencies are popping up and lists are separated out by our classifications. From this view, a dispatch agent can go into one of these crowdsourced images and get more info, set up some tasks, or change status. There's also an admin view that pretty much delivers the same information, but includes lat and long for sending along GPS coordinates. We can go into some details here as well. And we can zoom into the map and take a look at what's going on around where I live. Let's snap some photos of the activity going on in my neighborhood. The mobile interface for the app is simple, a map and a button to take photos when you see trouble. Oh boy, here's a really bad car accident. Let's grab a photo of it. When I take the photo, the response app kicks into gear. It processes the image and sends it out to our custom vision API, returning an immediate assessment of the incident. Yep, sure looks like a car crash to the API. I'm going to input a comment. Now, because I can't type in a foreign language, I'm going to cheat here and ask Google to translate this comment to Hindi for me. And now I'll click Done. In the background, the response app is sending the comment I made to Azure's Translate for processing. This is valuable because anyone can submit a photo and provide information in their native language, and the dispatch person will be able to read and understand it so they can action on it quicker in their native language. I'm going to loop around the corner because I smell smoke. Holy shnikes, that's quite a blaze! Once again, the Custom Vision API is pretty certain this is a fire. Now, one of the considerations that needs to be made with these two incidents coming back to back is figuring out how to prioritize them. In theory, this could be done numerous ways, including using AI to do further assessments to see what and how much response is necessary to tend to each incident. For now, we're going to head back to the dashboard and see what appears in front of our dispatcher. Looks like the two emergencies I spotted landed in the dashboard, and you can see the comment from the car crash has been translated. Clicking into the car accident, we can see the event type has been pre-selected based on the tag predictions, and the same goes for the house fire. For the lat and long, we're not grabbing the EXIF data off the image, although that is a possibility. Instead, we're using the phone's location to determine where the incident is occurring. If we zoom in, there's quite a bit of activity going on in my neighborhood right now. Oh wow! Did you hear that? It sounded like an explosion. I'm going to go check it out. It's a car that's on fire. Let's see how the Custom Vision API does on this image. Well, it didn't detect a crash and a fire, but it probably needs more training to distinguish between a car fire and a car crash. Let's try another one. This car is seriously on fire. And the API agrees. Okay, last one. Something a little bit more cuddly. That's not a cat, although it is a very fluffy dog. So how does this all work? Well, let's take a look at what it requires on the Mendix side of the equation. What I've learned prepping for this webinar is that there's still some wrinkles and potential gotchas you'll want to look out for when implementing cognitive services, especially with native mobile like this app is built. The whole process kicks off on the home page, the one with the camera button in the map that we saw earlier. The button invokes the Take Photo NanoFlow, and it's pretty standard. That is until you look under the hood of the Take Picture activity. If you're not familiar with NanoFlows, they're functions that run on the client, and because of that, they behave a little bit different than server-side functions, but in a good way, especially if you're building offline applications. Upon closer inspection of this Take Picture activity, it's a modification of the activity that comes with the native mobile starter app that just takes the picture. I've edited it so that I can run the Custom Vision API through it as soon as the image has been accepted by the camera widget. So in addition to the camera properties, there are a number of props for the custom API. The reason I bundled them together is more because native mobile capabilities are still in beta, but it serves some really good learnings on the JavaScript action side. If we inspect this action further, we'll see that it is actually a JavaScript action. And so it's designed to run on the client, or in this case, the mobile device that I'm using. Let's go into the code to see what's happening here. Everything runs from this first return. So this take picture is the camera doing its job. Then after that, we get the blob, the binary representation of the image. So we can pretty much do everything else. Once we have the blob, we send that to Azure to perform the analysis on the image. And once that's finished, the file gets stored in the database. Let's run through the functions. The take picture function works based on the method selected. So it doesn't have to be the camera where the image comes from. The getBlob function looks at the file URL and gets the content of the image. This is the most important part of the overall action. The getAI function sends the image to Azure and processes the response. This top part calls the REST API for custom vision. And this bottom part separates the predictions and creates references between them and the emergency response incident. After that, storing the file for later use just makes sense. And my one cautionary tale from this experience is think about the order of operations. When I first started building this out, I thought I needed to use a file reader to transform the file that was already in hand into a blob. It slowed the app down to a crawl and made it unusable. So I've left this function in here as a reminder of what not to do. So that's what happens when a picture is taken. So what about the rest? The event details page holds the button that saves all the information to the database, but it does it in a special way. It actually uses a before commit function that's attached to the emergency response entity to process the categorization and translation activities server side. If we take a closer look at these functions, they reveal how the final category assessment for an image is made and how the translate works. For translation, it's a REST API call to Azure's translation service. What's cool about Azure's service is it auto-detects the language and sends back what it thinks are the possible source languages. I want to take a moment to show you there is a server-side version of the Custom Vision API that we use today, and that call is in this app. And it's much more straightforward because it makes a REST call out to the service and uses an import mapping to bring the information back into the app. So that's the deep dive into the workings of cognitive services and with Mendix, or at least working with Azure's cognitive services with Mendix. Let's go ahead and take some Q&A.
All right, thank you very much for the presentation, Jeff and Adlai. I think it was really interesting. Let's go to the Q&A. We have some questions coming in. If you have any questions for our presenters, please use the Q&A window in the top left, and we'll get them here, and we'll try to answer all the questions as best we can. So let's see, one of the first questions that we have is, are there any concerns about building apps with third-party extensions from a security standpoint?
Yeah, I'll take this one, Jan. That's a really good question. And when you go to the App Store to use these third-party extensions that you can download from the reusable repository, you'll see that some have platform support, and those are are extensions that have been built through Mendix and are officially supported through Mendix, and then there are ones that have extended support, which do that have extended support through Mendix. And then most of them you'll see are community support. So the community support options are supported typically by the developers that make them. And in a lot of cases, the contributors to those extensions are also people at Mendix, but don't necessarily work in our R&D organization, so they offer their own support, or they're partners who are making different integrations available. As always, I'd recommend, make sure that you do thorough testing and that you do some inspection on your own to make sure that it meets your standards. But certainly, for the most part, the quality seems to be high, and folks are trying to commit to those high standards and keep up the integrations that they make available.
All right, so here's another question. Actually, maybe two questions. So can you run a POC or trial for testing this? And a follow-up would be, what are the costs of the servers if you want to run this?
Yeah, those are both really good questions. Adelaide, do you want to take the first part in terms of what you signed up for when you built this?
Yeah, so really easy to go and sign up for this in Azure, and they have a nice free trial that'll last you a while, and then you can convert it to a pay-as-you-go subscription. And if you use the entry level, then it only starts charging you after something like 1,000 calls, and it lets you have up to 5,000 images. So you can really mess around with this without even paying at all.
Yeah, and in terms of some of the pricing, I mentioned earlier that the pricing is pretty transparent. All of the vendors have their pricing out on their websites. When it comes to custom vision with Microsoft, as Adelaide was just mentioning, right, you can have 5,000 training images per project, and then you can perform 10,000 predictions per month. You can have up to 2 projects, and you can run training for up to 1 hour per month. Once you start getting into the standard and some of the other SLAs, there are other things. So it's $2 per 1,000 transactions. There's compute time that you can buy so that you can train the model to be more accurate, and then you can also store more images, which will also help the accuracy of your predictions. Google's pricing is a little bit different than Azure, so definitely take a look at that, and I'm sure Amazon and IBM and SAP also have their own pricing structures.
All right. A really good question here. Can these learns be shared? So all of this in the webinar. So this webinar is being recorded and will be made available to everyone here and to everyone afterwards. So we will be sharing this. You'll get an email with a link to the recording, and we'll make sure you get all this content afterwards as well, definitely. All right, so another question here. Are the photos that we sent, are they stored in Mendix or Microsoft during the AI process? And what about the data privacy issues here?
Yeah, that's a good question. So in this particular example, the photo is being stored in Mendix. It's actually not being stored on the phone. It's being stored in the Mendix application. And then you can choose to send that photo and have it stored in your project for later use through another API, because you can have it do a prediction, or you can have it do a prediction and learn, in which case you're sending it, you're doing prediction, and then you're actually confirming that and then sending the image for it to learn. Certainly, when it comes to data privacy issues, you will want to be using images that, in your training that are satisfying that certainly, and you can see from this particular example, we steered away purposefully from face recognition and that sort of stuff because of the increasing, anxiety, privacy issues surrounding facial recognition. You have some municipalities here in the States that are actually banning the use of facial recognition. So there's definitely things you need to consider, whether that's by providing some form of terms of service for whatever you would implement, or some sort of disclaimer when you use something like this. That would definitely be something you want to be careful with.
All right. There is a question from Lauren van der Vries. What were the main reasons to do the API call in the JavaScript action? Is that just for client-side reasons, or is there something else?
Yeah, it's a great question. So you definitely can do both, right? And we've, for the most part, based on our hybrid applications, hybrid mobile applications, typically we've built these through Java Actions and on the server side. I think, for this example, what we felt was really important for the use case is that when you took the picture, you were able to see the results of the prediction immediately. And in a hybrid use case, you'd be able to do that if you were working online with the native mobile capabilities, which we're using here, which are in beta. We, in order to facilitate that capability, you've got to do it on the client so that you get that immediate feedback, partially because of the fact that the native mobile capabilities are in beta, so calling microflows isn't something that is an option right now. It will be at some point, in which case you could go back to using the server-side modules that you need. But it's really player's choice. It all depends, I think, on where you're going to be able to get the best bang or leverage based on how you're building the API. But I see value in actually building both server-side and client-side versions depending on use case.
Yeah, and I think maybe a good follow-up question here as well is, are these native mobile capabilities the same for iOS and Android versions? So looking at platform support for mobile platforms, how does that work? Is there a difference?
Yeah, so our native mobile capabilities, which are in beta right now, are building React native applications. So when you build a React native application, that application is compiling and can work both on it's cross-platform. So you're essentially building once, and then you can deploy to, or when it goes into production, you'll be able to deploy to the environment of your choice. That's one of the beautiful things about using React Native is that it takes on the styling of iOS or Android based on where it's deployed.
So there's a question here from Horace Tang, and he says, will Mendix be creating modules for cognitive services that we can configure and use, or will we have to integrate with the CS APIs ourselves?
I can take this one. There's actually already a few modules in the public App Store for integrating with the cognitive services. But as Jeff and I showed in just a few minutes ago, it's really easy to just go right-click and add a REST API and consume it in a Mendix app. So if there's additional cognitive services that we don't have modules for in the App Store, then you can really easily create your own or take one that we have and modify it based on one that we haven't built a support for yet.
All right. So does Google have an API like Custom Vision? I see this AutoML. How is that different from Azure?
It's not really that much different. I've only taken a cursory look at AutoML. It's kind of a brand that Google is using for anything that is adding an additional layer over just the simple detection of text or stuff like that. I think where you can add more tagging so you can do predictive work. I'd say it's probably not much different, but Google is really at the forefront of a lot of this artificial intelligence and machine learning algorithm development, as well as a lot of the standards and best practice that data scientists are using to build their algorithms. I was actually just on a webinar an hour before with another company called Pelterion, which does operational AI, and they were talking about some very technical topics in the world of artificial intelligence and machine learning, and they were mentioning Google's Transformer, which is a new system for building out machine learning algorithms and doing deep learning and stuff like that. So there's definitely potential that there's differences between the services and what you can do with them, and we'll be continuing to dig into this topic as time goes on to see what those differences are and sharing that with you.
Sounds very good. So how much time do you need to develop an application like this, or an AI application that's ready for production, basically?
Yeah, so Adlai, how long did it take you to get the AI trained for this emergency response use case?
I'd say less than 10 minutes.
That's not very long at all. Yeah, and I think
I was expecting 3 to 5 hours.
I had to figure it out first,
yeah.
But once I figured it out.
Yeah, I think it's really interesting, the use of these services, and it goes back to that point about the 80% of the value for 20% of the effort that I mentioned earlier, is that you can actually do a lot with a little bit of time investment, not only on the Mendix side, but also on the actual application of the machine learning or artificial intelligence piece. Now, if you're looking at something to do it for production purposes, you are going to spend more time and effort, and it goes, and I highly recommend reading the articles that I mentioned earlier, talking about some of the different things that you want to do in order to support that, so that you're doing it right and that you're measuring what your return on investment is going to be and how much training is going to be required based on what your use case is. But for this particular application, this emergency response application, like Adlai said, I think it took you 10 or 15 minutes to train the AI. It took, I'd say, probably a couple of hours to set up the reusable component, and then, if that, and then building the app. Mike Schiraldi, I think, built that app in a couple of days, integrating those capabilities and coming up with that methodology. So you can move pretty quickly, at the very least to an MVP stage, and then after that, as you're iterating, it just your cycle times for delivering new capabilities or new experiences just accelerates.
Yeah. And so on the deployment side, there's a question here about cloud providers. So if Mendix works with other cloud providers like AWS, Alibaba, Google, or if there's even a hybrid cloud setup. And, I think we have a very simple answer to that. I think you can talk more about that, Adlai?
Yeah, so essentially, Mendix applications can deploy into any cloud environment. So we have our Mendix cloud, and then into any other environment that you're interested in.
Yeah, I'll add on to that the reason why that is that the way that we package applications, either using Cloud Foundry or Docker and Kubernetes, it gives you flexibility to deploy to your own private clouds. We have connectivity through our platform portal to IBM, SAP Cloud, but we also have capabilities to deploy on Red Hat OpenShift, on AWS, on Azure, and then other clouds like Alibaba and Google are definitely a possibility.
All right then. So let's see if we can do a couple more questions, if that's okay with you guys. So here's the question: how do you actually deploy the Mendix app to iOS? Right? You built an app, it's working. How do you get it in there?
Yep. So great question. I can't answer that in terms of our new native mobile capabilities, but with our current build process, building hybrid mobile applications with Mendix 7, the way that it works is you can use Cordova and PhoneGap to actually build your applications for the specific app stores, and you can build it for both. And you do that through the platform portal. So once you have your application committed to Team Server, you go into the platform portal, and there is a deploy for mobile option, and then it takes you through adding specific screens and information that you would supply for your App Store builds.
All right. So basically, the Mendix platform takes care of all of that, and you don't have to do anything outside of the platform, any custom things.
No. Nope.
So do you need to use Mendix 8 to use cognitive services? And the things that you showed, is this like early version? Is it beta? Is it, can people use this? Can they build it right now?
People can build this right now.
Sorry, Adelaide, go ahead.
So this is functionality that is in Mendix 7 and I believe 5 and 6 as well. So this you can go ahead and start integrating with any cognitive service or anything for that matter that uses the REST API functionality out of the box right now.
Excellent. Free AI for everyone. Woo!
I wouldn't call it free, but.
All right. Yeah, so people are asking if they can get the slides, and I'll just mention again that we record all of this, so this will be posted afterwards. You can view it on video.mendix.com as well, and we'll send an email to everyone who attended the webinar where they can find extra information. So a little side question here is if there is a possibility of sharing some guidance about image content. So this is going into, I think, what you showed, Adlai, about images. So what about count, file size, as well as file type? Can you share some more about what you need to use for AI model trainings? Is there anything that you'd recommend?
So there's some good guidelines on Azure's website that dive in deeply. I believe it doesn't let you have an image over 2 megabytes. But then in general, to train a good custom vision algorithm, you want to have a picture of the same item. So say we're training that cat in a tree. You don't want that cat in a tree from the same angle. You want it with different angles and different lighting, so that the algorithm can really learn what that item looks like in general and not just the specific way you're looking at it. So that's kind of the guideline.
Great, sounds good. So with that, I would like to round up the webinar. I want to thank Jeff and Adlai for doing this presentation and showing us and teaching us about AI and how to train a model. and especially how easy it is to simply build an app that can do this. If you'd like to learn more, we have a lot of resources on our website, mendix.com, and we have videos, blogs, and webinars, and more content. Also, make sure if you're in the neighborhood, try to attend one of our meetups. You'll be able to speak about these topics with expert Mendix developers, but also people from Mendix themselves to find out what's going on. What's coming, what's in the future for the platform, and all the technologies that we're integrating with. So thank you all for joining, and we'll see you at the next webinar.
Thanks, Jan.
Thank you.
Thank you. Bye.
Thanks, everyone. Bye-bye.